Alright, so we got 1,200 centimeters squared of material available to make a box with a square base and an open top. Find the largest possible volume of the box. Well, it's a square base, so that tells me let's call that x, and that's also going to be x. And then we have those two back sides that are going to be x as well. And let's call the height h. So let's think about all of these surfaces of the box we have. Well, this is going to look like this if you drew a net for it. It's going to have an x by x base, so then that's going to be x, 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 and then everything else is going to be the height there. Height, 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 height. Which is now a terrible diagram because I put way too much stuff on there. But if you think about it, we have two things going on. We have rectangles that are x by h, and we have 4 of those. And we have one rectangle, or one square to be more specific, that is x by x. And there's only one of those. So the surface area, which is 1,200 centimeters squared, is going to go into 4xh plus x squared. But we're not interested in the surface area, we're interested in the volume. So again, let's go ahead and simplify this a little bit so we can substitute. And we're going to solve this for x. So we're going to get 1,200 minus x squared over 4x. And I said solve it for x, I meant to say solve it for h. We're solving that for h. We get 1,200 minus x squared over 4x. And now let's substitute that into our area equation. Well, let's write our area equation first off. Area, I'm sorry, not area, our volume equation. Volume is going to equal the area of the base, which is x squared, times the height. And again, the height is going to be that expression there. So we're going to get x squared times 1,200 minus x squared over 4x. So now again we want to find our domain, so let's look at that numerator, 1,200 minus x squared. Let's set that equal to 0. So then we get 1,200 equals x squared. So if we take the square root of that, we should find a 0 to this function. So square root of 1,200 is 34.65. So I'm going to make my x max 35, and we'll see what happens. So when I zoom fit it, it gives me a y max of 4,000 up here. And again, y is representing the volume. Y min is 0 there. And the graph looks pretty awesome, just like that. And so, find the largest possible volume of the box. Well, the largest possible volume of the box is 4,000, and we are talking about centimeters cubed. And let's go dimensions though real quick, just for fun. X is going to equal 20, and then the height of the box is going to be 1,200 minus 20 squared over 4x. So let's do that real quick. I dropped my pen. And you should get h equals 10. And if you're doing this problem and you feel like you set everything up correctly but you didn't get the right answer, remember that if you are doing this on a TI-83 or a TI-84 that doesn't have the updated operating system, you have to put that denominator of 4x, and you should also put that numerator 1,200 minus x squared in its own set of parentheses. Otherwise, your calculator is going to interpret it differently, and you're going to get wrong answers and you're going to cry.